Howdy, this is Jim Rutt, and this is The Jim Rutt Show. Listeners have asked us to provide pointers to some of the resources we talk about on the show. We now have links to books and articles referenced in recent podcasts that are available on our website. We also offer full transcripts. Go to jimruttshow.com. That's jimruttshow.com. Today's guest is Lawrence Cahoone. Lawrence is a professor emeritus in philosophy at Holy Cross College. Cahoone's areas of specialization in philosophy are American philosophy, continental philosophy, social and political philosophy, philosophy of culture, metaphysics and natural science, and modernism and postmodernism. And he's written 7 books in his career on philosophy. So you say those are your specializations, Lawrence. Doesn't sound very specialized to me.
Right. I agree.
It's like 80% of the curriculum in philosophy right there, right?
I know, and this fact has been noticed. Essentially, I would say that by this point, I'm a systematic philosopher, which is kind of a dirty word in philosophy for good reasons, historical reasons. What I would just say is I'm not trying to create a system, but I am trying to see how different areas of inquiry in which I've spent a chunk of time, each of those represented by that list, and I'm trying to see how they hang together. Wilfrid Sellars, who was a really important philosopher from the 50s to the 70s, he said philosophy is basically the attempt to see how things in the broadest sense of the term hang together in the broadest sense of the term. And that's what I'm trying to do. Although I would say that's actually a really good definition of metaphysics, not of all philosophy, but of metaphysics. But yeah, so I'm trying to see how they hang together. And so roughly speaking, you can say that my goals are to find decent local characterizations of different aspects of the real in different domains and subject matters, but in such a way that I can relate them. So
that came out in the book. Lawrence's most recent book is The Emergence of Value, Human Norms in a Natural World. It's now on my reading stack and getting pretty close to the top, so I'm looking forward to reading that. But the one we're going to talk about today is The Orders of Nature. This book was recommended to me by my friend Greg Henriques, and sure enough, I really did enjoy it. It's a very good attempt at what Lawrence just talked about, is to explain it all down at City Hall, right? In a way that did not even offend me. You know, as regular listeners know, I have been known to say, when I heard the word metaphysics, I reached for my pistol. In fact, there's a fair number of Rutt fanboys and girls who have posted AI versions of the metaphysical pistol, which is kind of cool. But I didn't even pull out a knife for this one. This one didn't offend me hardly at all. But we're going to get into it and talk about it. One of the things I should mention, I was very pleased to see that you mentioned Prigozhin quite a bit, 14 times by my count. And it's interesting, you know, people are either Prigozhinists or try to whitewash him out of history. And, I find that if you're going to try to talk about a world based in emergence, it's really pretty hard to do so sensibly without talking about Prigozhin.
I mean, from my point of view, again, I'm not a scientist and I'm not a scholar of the Belgian school, but right, he's crucial as far as I can tell.
Yeah, it's interesting. At the Santa Fe Institute, where I spent a lot of time, a lot of people are anti-Prigozhinists there. It's quite interesting.
What's their beef?
Truthfully, I don't remember. I just disagree. I'm moving on. Sorry. You mentioned you're not a scientist, but I got to say that the quality of your explanation of even quite deep scientific principles was very good. And in fact, your descriptions of general relativity, special relativity, and quantum mechanics, I would really recommend to people as excellent educated layman's definitions of those terms.
Thank you.
How much science did you have in your background to be able to do that?
None.
None.
But what I did have was friends. So I had always, as an undergraduate, I had an interest. My interests were mainly in philosophy and psychology, but I did have an interest in the history of science. And then when I was in graduate school, I did some history of science and took a course with Patrick Heelan, who had the double PhD in physics and philosophy. But it was only, for a while I was teaching at Boston University, which has a bunch of strong faculty in philosophy of science. And I basically, sat in on courses and, got a copy of Sears and Szymanski and outlined the book. And then just, got Feynman's lectures on physics and then spent a few years. So, I mean, it's still qualitative, but my goal was to get to the point where I can't do the math, but where my standard for myself was, you're never going to do the math unless you go back to school for 10 years. But you can get to the point where you can see what the math is doing.
Oh, I'm going to tell you a little trick if you want to learn. My math skills are good, but they don't go all the way to as far as they could. So you can take a scientific paper that you don't really know the math, pull it out, put it in a high-end LLM, like Anthropic Opus 4.1 or the new OpenAI 5 Pro are both good at this, and ask it the following question: explain this section in the context of the paper, and load the paper up also, as you would explain it to an 8th grader. And it'll be very long, but very simple. And I found that works great. And then if I understand it at that level, I say, okay, now explain it to me as you'd explain it to a college sophomore. And then it will do a tighter job, less words. And generally I'll say, okay, that's all I need to know. I need a college sophomore level. And even in domains where I don't understand the math at all, that little trick works.
Right. I mean, in the midst of, so this is before AI, or at least before I knew anything about it. For me, it was just collecting the right people. I mean, and that's the mathematician here who's a colleague, and a big help to him was a guy named Tianyu Cao, who's a philosopher of physics at Boston University. And I would write stuff, and he would read it, and he'd say, "Oh God, no!" And I would write some more. And one part of it is too, you also, when you're discussing fields, and it's not just in the natural sciences, you don't want an explanation that's too simple either. People just throwing pleasant metaphors at you, where you don't understand. The conversation's over, and you're hungry an hour later. And they got to find the level at which they can communicate with you, and you learn stuff that you didn't know before.
Yeah, and I'd say you did a very good job of that. In general relativity, it's really easy to say rubber sheet, ball bearing, right? But you went quite a bit beyond that, and I thought it was all very good. Anyway, let's hop into the book. And you start out by stating that you are going to start with a fallibilist and local metaphysics. Why don't you explain what you mean by that? To me, it may be a term of art in your area of physics, but metaphysics. I'd never heard the term local metaphysics before.
So just to kind of organize things. So the naturalism that I develop, I'm a naturalist, and it's got two things that make it distinctive, not unique, but distinctive. One is the notion of emergence, right? And that's something you and I share. The other thing is my background notion of metaphysics is tied to a view called objective relativism. And that objective, not subjective, objective relativism, that is a very little known doctrine. It was developed by really the first school of philosophical naturalism in the United States. Philosophical was at Columbia in the middle of the 20th century. Everybody calls it Columbia naturalism. And the Columbia naturalists had this doctrine they called objective relativism. And what it essentially meant was, first of all, the Columbia naturalists, they certainly believed, they rejected the existence of anything supernatural, which you pretty much have to if you're going to be a naturalist. They then accepted that all qualities and features of human life and experience are as natural as anything else in nature. In other words, they're all It's all equally natural. Okay. But then they added this objective relativism, which said, we don't know what it's like or what it means to say that an object exists in isolation. To talk about anything, we have to talk about how it's related to other things. And those relations have an impact on its properties and what it is. What does that lead to? Well, it leads to a couple of things. At two different ends of sort of the spectrum, it means there are no simples. A simple would be something which can't be divided into parts, okay, which does not differ from one context of operation to another. In other words, its relations to things outside itself make no difference to how it behaves. Like the old Democritean view of atoms, the old that or the billiard ball view that people used. If you say all of reality is an artifact of or created by a bunch of simple particles where the particles have no parts and the particles are eternally, at least the Democriteans thought this, the ancient atomists, they're just eternal little building blocks and all that changes is they move around and recombine in different ways. But the particles themselves are completely independent of each other. And in other words, if you took one particle out of the universe, it would be the same as if it were in the universe. That would be a simple.
Compare that to, let's say, a proton. All right, a proton may not be good because we know it's made of quarks. How about an electron, which we think is so far at least, every electron is identical. In fact, John Wheeler went so far as to say, well, the only possible explanation could be is there's a wormhole that connects the whole universe and there's only one electron because they're that similar.
Right. So you're asking me the question, well, gee,
no simples. What about electrons?
Cahoone, aren't there simples? There seem like they're simples, like maybe quarks and electrons. So here's what I would say. Now, this is the edge of the universe here, the edge of all scales, but I would still apply it there. Namely, first of all, we don't know what the future is going to hold. So we don't know that we're not going to find out that electrons are subject to further analysis. Okay? But let's say for the time being, physics works by regarding them as simples. But the other thing is, in field theory, an electron is something like a localized intensification of energy in a field. And fields aren't simples. Whatever fields are, they're not simples. So as soon as I try to ask what an electron is, I get an analysis which isn't simple at all.
It's certainly not a billiard ball bouncing around in the universe. It's tied into, yet at the same time, the rest mass of every electron is identical to about as many decimal points as you can measure.
That's right. So they're all highly similar. If you want to say the same, they're not, we still count them as numerically distinct. That is, there's one electron and then another electron. They're not the same electron, but that they all seem to occupy this same energy value. Okay. And that's fine. But the point is, as we analyze the way Justice Buckler, who's one of the people who influenced me, and he gave the most coherent explanation of objective relativism. He would say, if something's a simple, then it is no longer capable of further analysis. And his view was, we don't know of any such thing. And I would say, too, that the electron is capable of further analysis. And the fact that it's a field phenomenon shows that.
Okay. All right. So let's continue with the story.
Let me just go to the other end, though, just to say this, and then we'll get done with objective relativism. And there's a reason that this complicated little scheme lies behind my naturalism. At the other end of the scale, the objective relativists never use the term everything, the whole, the one, the all-encompassing context of everything. All we can do is find things and see in what context they operate. That's what we do. Now, we can get bigger and bigger contexts in which we operate, but we're fallibilists. We never know everything. We can't ever claim to have gotten the context for everything. So the process of analysis, in terms of bigger and bigger and smaller, there is no endpoint for it to get to. And one way that Lawrence Cahoone, who was one of the contributors to this Columbian naturalism view, the way he put it was, the question about anything we bring up that we want to look at or understand or account for isn't, is it real or not? The question is, how is it real? In what context of relations does it function?
I like that. That's good.
So that's what I'm using to look at the things which I then say can be encapsulated in naturalism.
And as I mentioned earlier before show, I also call my own metaphysics naturalism. And as I also warned, I could describe it in one sentence, which is materialism, which grants emergences first-class existence in the universe equal to electrons and quarks.
Which admits existence's first-class existence? Could you explain that part?
Yes. Emergence is a first-class existence. So emergent phenomena, like a star, for instance, probably the most important emergent phenomenon in the history of the universe so far, or life, one or the other, is a star is a thing. It's real. It's the dynamics that make the star cohere for billions of years is every bit as real as an electron or a quark. And the failure to understand that distinction is, I think, where materialism materialism can have a bad name, where it doesn't acknowledge emergence as a first-class phenomenon.
Right. I totally accept that. Personally, I like to distinguish between the physical and the material. So I would say, the order of nature on which everything else seems to be partly based, partly dependent, is the physical, because physics examines a bunch of stuff that's not material. But the general idea, yes. And if I understand the thrust of what you're saying, the taste of the apple is real. The apple is real. Your thoughts about it are real. The molecules composing the apple are real. The star where some of the atoms were formed is real. And the Big Bang from which the star eventually came, that's real too.
Exactly. That's essentially my point. It's all real, guys, right?
Yes, it's all real. And here I'll actually mention, there's this view in the philosophy of physics called structural realism, which I don't know if they're still around now. They probably are, but they're trying to claim that as physics advances, what we find more and more is it's not the stuff that matters, it's the structure, the rules of combination that matter. And I don't doubt that that's to some extent true. But there's a book by one of the structural realists. He wrote a book in which he basically, the title of the book is Everything Must Go. And he meant not refer to any entities at all as real. Just the structures of like contemporary microphysics or something. And I would say everything's real. The total opposite. Nothing must go. The question is just, how do they function together and interact?
All right, so that's a great introduction. So within that context, what brought you to use the term local metaphysics?
Well, the local part is really just from the objective relativism, or it's an application of it. So here's what I mean. When I'm doing metaphysics, I'm trying to see how things hang together. If someone asks me, I want you to give me a characterization of the absolute foundation of everything else, that on which everything is based or causes everything else. Or if you ask me, you have to give me a characterization of the one, the whole with a capital W, I'm going to say, I'm not that interested. I'm interested in the middle, and I'm interested in all the various things, which all the aspects of reality, the entities, the structures, and the processes, how they interact. And I move from one locale to another, and I get bigger. But in no moment am I going to answer the question, what is everything?
Or what is the foundations either? I always call myself an anti-foundationalist, and this I was a libido for firm foundation strikes me as one of the worst bugs in human cognition.
There's a quote that I use, I think in that book, from Feynman, where from the Character of Physical Law, where Feynman says, okay, we seem to have in science a variety of levels and ways of talking about things. So we talk about fields and electromagnetic phenomena, and then we talk about molecules and tensile strength and melting point, boiling point. And then we talk about things like cells and life processes, and then we talk about organisms, and then he keeps going up in terms of scale, and then he says, and finally we get to the biggest scale, which is God, beauty, and hope. Now then he says, I should say, he doesn't say God, he says beauty and hope, the beauty, the highest ideals, beauty and hope. And he says, now which end of the scale, from the microphysical scale to beauty and hope, which is closer to God? That's the question he asks. And the answer he gives himself is neither is closer to God. It's all the workers in the middle examining the ways that this complex, tremendous world of interacting hierarchies relate to each other to construct reality. That's what's nearest to God.
Amen. I'm going to have to dig that quote up. I don't remember it in the book, but that just really resonates with me, because I sometimes say, hey, people, we're just here in the middle, between the Planck length, we don't know anything about the physics, and cosmology at the top, we don't really know that much about it. But there's a lot of interesting stuff here in the scale between microns and light years, basically. And that's our game. We're people in the middle, and there's a lot to be learned, and there'll be probably millions of years of investigating the emergent complexity of the middle.
Furthermore, I would say, I completely agree. And I would just add to it, there's another epistemic reason for taking that attitude, which is our most robust forms of knowledge, meaning things we know through several different modalities, arguments, philosophical or logical arguments, multiple sensory modalities, including different observers all finding the same thing. Whatever we know most robustly, that's in the middle. We are perfectly able to then say, okay, on the basis of this, our knowledge of what's going on in the middle, let's now make guesses and speculate and try to find out about the end. And that's perfectly fine. That's good. But what we can never do is say, oh, until we get to the end point, our knowledge of the middle is up for grabs and we don't really know anything. That until we know everything, we can't know anything. If that were true, then the whole process of inquiry, we should abandon it now and just watch television. And then there's nothing to do.
And as we know about the history of ideas, they build one upon the other, right? And our tools get better and sharper. We learn new things. We extract new generalities. Then we get our tools get better. We do a Michelson-Morley experiment. We go, oops, we were wrong about that. And then we have to come up with a new theory, and then that has new experiments. So clearly human knowledge, at least, which may not be the remit of all knowledge, has always grown that way based on an intersection of our relatively weak mental skills plus our gradually evolving power to build probes.
Right. Yes.
So now let's move on to another. We are having a good time here, but we're also cooking through the clock, and we're just finished chapter 1. I'm going to skip chapter 2 on the history of naturalism, which is interesting and worth reading. But let's go in and pick into a little bit this topic we talked about in passing, which is really quite core to your work, and that is emergence contrasted with reductionism.
My notion of emergence is pretty much stolen from William Wimsatt. So he was a philosopher. His official job title was philosopher of biology at University of Chicago, and then I think in retirement he taught for a while in Minnesota. But he really he knows a lot about electrical engineering, and a whole bunch of, not too many philosophers can give you explanations of electrical engineering. He's a philosopher of science, and he gave his own notion of emergence. Wimsatt was part of philosophy of science, changed a lot in the 1970s and 80s. Just philosophers now. So philosophy of science really started in the United States in the 50s, especially with Ernest Nagel. And he was one of those Columbia naturalists. And he wrote like the first textbook on philosophy of science. But in those days, philosophy of science was all about philosophers reading science and giving a conceptual analysis of the scientists' arguments. And that was mostly positivism. Logical positivism was the result. And the only science anybody studied was physics. In the 70s and 80s, a couple of things happened. There was a new movement, and the University of Chicago was actually at the center of it, where the new view was something like, if you're going to do philosophy of science, you need to do some science. So you need to get into the lab and talk to scientists and see how the scientific mind works while it's figuring out new things. And at the same time, philosophy of biology came into existence. It didn't really exist before. Wimsatt's a product of those two things. And so his notion of emergence, his notion of emergence is, number one, emergence and reduction are not antithetical. Given a system, we try to explain its properties. Some of its properties may be fully explained reductively, which he means as an aggregation of components. In other words, that the property of the system is nothing more than the aggregation of properties of the components while the components behave under their interaction rules. But that could be true for some properties of the system, but not at all for others. So you have the same system. Some of its properties can be reduced and should be, but then others cannot be. And he calls those emergent. So emergence for him actually means non-aggregativity. And he's got some pretty cool criteria for how you determine these things. But let's just say, for example, rather than to drone on abstractly, if you roll me down an inclined plane, or better yet, throw me out of a window, physics can utterly explain my trajectory, the force with my momentum, the force with which I hit the ground. And so, like, the energy that will be transmitted into deforming my body when I hit the ground, okay? But if you want to talk about which of my organs fail, you're going to have to get into chemistry now and look at the tensile strength of my bones and this and that and what survives and what doesn't. If you get into my biology, okay, physics has nothing to say about my vomiting as I fall. The vomiting is, I don't know that physics can define vomiting in any way that's biologically accurate. And then when you get to my screaming curses while I'm falling, biology is no help. Now we need psychology and linguistics and a whole bunch of other things. So my system is partly explained, reducible to physics, partly reducible to molecular biology and chemistry, but then other things about me aren't at all that way. And they're just emergent, and there's no mysticism involved. There's just complexity that outstrips the particular concepts and rules of physics.
What we know, or at least a common usage of emergence, is that there is a series of levels of which each level is a set of new behaviors that are either unpredictable or so difficult to predict in advance from the interactions of the lower level components. And if we're talking life, the interaction of organic chemistry inside of a cell. If you just gave me a list of all the organic chemistry in the world and then said, okay, what is going to happen to describe life? You couldn't do it, right? Life is an emergent result of the interaction of organic chemistry, the interaction of multicellularity to produce animals that can move coherently and hunt and eat and digest and shit, is an emergence from multicellularity. Is there any difference between that view and Wimsatt's view?
No, he would just take it further.
Look at it the other way around. It sounds like he was talking about it from the lower level up. Look at it from both above and below.
Right. He's talking about from the lower level up. And he has some really interesting things to say about it. I'll just say quickly, one thing is, so some people distinguish weak and strong emergence, which to me is kind of like, where's the beef? I don't quite understand.
They're both terrible. As I hear my short form on that, weak emergence is too little, strong emergence is too much.
Well, and what I would say is, I would go a little further. Without downward causation, there's no point in emergence at all. So it's got to be the case that the system has certain properties, and that play a causal role, having an effect on the contribution the components make to the system. That is, the contribution the components are making to the system is being predigested or constrained by higher level properties. Those are emergent, and they're downwardly causing. That is, they make a difference to what's happening to those components.
Indeed. In fact, the first person that I ever had a serious conversation with about emergence was Harold Morowitz. And Harold's got a great book called The Emergence of Everything, talks about, I think, 28 levels of emergence. And the words he used, which have always stuck with me, is that he describes that downward causality in a less than strong but more than weak version as pruning rules, essentially, that the upper levels provide constraints on the lower levels without actually pushing them around. They change the trajectories, change the probabilities. The example I give is a bucket of the chemicals of Jim Rutt in a 55-gallon drum are very unlikely to decide to get up and walk to the store and buy a six-pack of beer. But one day Jim Rutt decides he wants to go to the store and get a six-pack of beer.
That broke up once you get to a bucket.
Okay, yeah. The bucket of Jim Rutt's chemicals are very unlikely to decide to get up, move down the road 2 blocks, buy a six-pack of beer, and walk home. While if Jim Rutt, the entity, decides he's thirsty, those chemicals could go for a ride that they weren't anticipating, or that would not be statistically predictable based on them being a bucket full of chemicals. And so hence the fact that these chemicals are organized in the body of Jim Rutt means that the trajectories that they are likely to make have been very substantially pruned from if those same chemicals were in a bucket someplace. And that's what I think Harold's really deep insight. It's not that the top is pushing the bottom around, it's that it's changing the trajectories and maybe probabilities in the landscape.
I mean, the last few years, I'd have to tell my student, give them a trigger warning before I would say this, but I said, if you give me a wearing blender and take a cute little bunny, put the bunny in the blender, turn down the blender, there'll be a momentary high-pitched squeal, and then just the whirring of the blender. Now, what we've got left is bunny soup. every physical and material component of the live bunny is in that blender. Nothing's escaped, nothing's missing. If you put a top on it, you can keep the air in its lungs in there too. The total bunny is there, but there's no money there. I mean, it's just not, you can't even identify it anymore as a rabbit, much less, and of course, obviously, there is nothing for biology to study anymore because it's not alive. And life has to be understood as a set of biological processes taking place in an organism in relation to an environment.
A little bit more abstractly, what's missing is the dynamics, right? And the amazing thing about life, if we think about it rigorously back to Luca, our last universal common ancestor, the dance of the molecules has never stopped, right? If it ever stopped on the chain, life would be over. But, every single one of our ancestors successfully reproduced, which is an eerie concept, that we are a very, very sparse graph with us at the end and a whole bunch of things that could have happened but didn't. The dynamics is what never failed, and this is the dynamics that is missing when you blend the bunny or put Jim in the bucket.
Correct. My tendency when I look at natural things is the objective relativists, not to go back to that, which is real abstract, but like Lawrence Cahoone and then Justice Buckler, their name for anything whatsoever that we discriminate and want to account for, not just things or entities, but possibilities, the past, thoughts, ideas, meanings, anything whatsoever, their name for any of those things, we've said, use the word complex. So we got complexes. Buckler called them natural complexes.
Yeah, that was where I'm going to go next. So let's talk about natural complexes, systems as natural complexes.
So Buckler presented the most pluralistic metaphysical system you could ever have. That I would claim that, which just says all we have are natural complexes, each of which functions in some order of relationships. And our job is to see how they function in those orders. And that's it. And part of it was none of them is more or less real than any other. That's what he called his principle of ontological parity.
And there's three parts to that he claimed, right? The component, structure, and process.
That's me.
That's you.
So
okay.
That's not Buckler. So Buckler presented this big pluralistic system. I come along, and I did study with Buckler. I came along, and I say, but that's not really naturalistic enough. That by itself doesn't give us naturalism.
Yeah, that could apply to systems that aren't our universe really easily, right?
Well, that too. There's certain problems in his theory that can't be solved. You got to put constraints on his. He's like a system which needs constraints to create a workable naturalistic metaphysics.
Ah, nicely said. Nicely said.
So what are my constraints? Well, here's one of them. Out of all the various things in the world, I'm going to focus on systems. Not everything's a system. I mean, oxidation isn't a system. It's a process. Triangularity isn't a system. It's a form or structure. Okay? States and events aren't systems. But I'm going to focus on systems, but with any system, I am regarding the system, its components, which are littler systems, the structure of the system, so component structure, and then the process that maintains the components in that structure. What I'm saying is systems are components, what we might call things or substances. Systems are components, processes, and structures have what Buckler called ontological parity. I mean, they're equally real. It makes no sense to say one's more real than the other. They're all real. Without any of them, things fall apart. So when I look at a system, I'm looking at it as a collection of components organized in a structure through some kind of process, and of course then in interaction with a larger environment. So this would be the sense in which there are a lot of philosophers who in the 20th century have said we got to get away from substances, entities, medium-sized physical objects, or stop thinking of the world as just a collection of entities, and we have to see it as process, dynamics, things running around. Or when you think of it as a big structure, that's what the structural realists would say. My point of view, kind of derived from Buckler, is it's all three of those things. We don't know what a process is without something undergoing it. We don't know what a thing is without any structure. We don't know a structure without things being structured. And so systems with their components and processes and structures, these are all equally real, and we just want to see how they relate to each other.
Yeah, and then that fits the words I use, which is the dynamics of the system are essentially a different point of view on the process, the components that result in some form of maybe not stable, but dynamical structure.
That's right. And structure doesn't have to be dynamical. And, there's a lot of kinds of systems in the world. I mean, a cloud, as Karl Popper pointed out, some things are like clocks and some things are like clouds. So, we got relatively well entified objects like a clock, which has, unless you put the temperature up too high, it's going to keep kicking and doing what it's supposed to do for a long time, longer than I can stay alive, for example. So it has a lot of stability. That's a kind of classical entity. The cloud's different, but it's still a something. I mean, the cloud's a system, but a system without a lot of structure and highly variable in terms of environmental conditions. And then, of course, there's even fields, which are a whole separate thing. But there's different kinds of systems.
Gotcha. And that's good. I think I like that. And now let's move on to the next part that you talk about with respect to these systems is law, causality, and complexity. First, let's talk about law. This is something that is law. I always like to put it in quotes, particularly when you're talking about emergence. Sometimes I'll say maybe there's a lawful realm at the very bottom, but the things we think of as laws in the emergent space, they're a little on the loosey-goosey side. But so what do you mean when you say laws?
Well, I just mean that we have discovered that the behavior of some type of system follows a rule. And how hard and fast it follows that is going to be variable. But whenever you follow, there's going to be, and it seems to me, you can have laws or rules at any level of the hierarchy of reality. It's just they're different kinds and they come from different places.
Give a couple of examples so we can, land this for the audience a little bit.
My son was in a marching band. When they're moving around the field, these little particles, which are sophisticated primate organisms, and they're moving in a highly governed way, and you could predict how they're going to move. Now, there will be errors and mistakes, okay? So there will be indeterminacies, like a little cloud hovering around the line, okay? But it's still the case that they're following a rule. Now, human beings follow rules all the time, especially in the use of words. So this is a different kind of thing, of course. These are now rules created by humans in social interactions. But let's go down a level. I wish I could remember. I'm always forgetting it. There's a rule in ecology. I'm a fallibilist anyway. It doesn't have to be certain to be a law, because I don't think we're getting certainty, period. We're getting fallible advances in knowledge. So I'm happy to call that a rule. I'm happy to call that a law. And if you can show that it does correctly describe through testing and evidence, a great majority of what goes on in an ecosystem, then that's a rule.
Interesting. I just remembered where I had heard of Wimsatt before, not somebody I had read carefully, but I did read something of his on heuristics a long time ago.
That's him.
I'm a great believer that we underestimate the importance of heuristics, and it had to do with artificial intelligence. I believe that a lot of the road to artificial general intelligence is going to be around heuristic induction. And so far, nobody's working on that. And I read Wimsatt on heuristics. So is there any distinction in your fallibilist taxonomy between a law, a rule, and a heuristic?
Well, if I understand heuristics, and the stuff I've read from Wimsatt on heuristics is part of his, he's wrote a zillion essays, but then thank God he actually published a book, which is a collection of essays. So if you read those, you pretty much know what he thinks. And the first few are on heuristics, rules of thumb, by which we try to understand their hypothetical projections that we make, and then we see how wrong are we, and that's how intelligence works in lots and lots of cases. And I mean, I think that's widely true.
The question is, where's the line? So, when I talk about
the line between what and what?
Between heuristics and a law, or heuristics and a rule. Like, for instance, I think of heuristics as rules of thumb that are computationally inexpensive, and this is important.
Mm-hmm. Okay.
That allow you to make predictions that are useful against some measure, right? In evolution, the measure is successfully reproduced, right? Or at least collective, inclusive fitness. But there's other things. For instance, I would say it's a heuristic that when the band is marching to the straight ahead, and then they have this complicated maneuver to turn to the right. I would say maybe just a heuristic that everybody will turn to the right, because there's always Billy Bob who smuggled the pocket flask of Southern Comfort, hit it way too heavy, and kept marching straight. So it's not a law like, say the Pauli exclusion principle, or even the species exclusion principle, which is a higher level loose.
So here's my deal, and I don't know that I have any great wisdom on this issue. The heuristic I understand as a pragmatic rule of thumb. If it's accurate enough, useful enough that you can now state it as a rule for the behavior of certain variables in relation to each other, then I'm happy to call that a law. If there are exceptions to the law, I don't get too upset. I just say it's a law in that we're evolving a law, and we're not there yet. I come out of the Peircean tradition, and Peirce's point was one of Peirce's points, and now this is like a different thing, but it's in the back of my head all the time. Peirce spent a lot of his time, he was actually working on the U.S. Coast and Geodetic Survey, wandering around, making photometric studies, like of the light intensity in different places at times in New England. And I was doing this measuring stuff, not just sitting in his office at Harvard. And he claims that, this is why Peirce is not a determinist. Peirce says, we have laws. The laws determine particular cases to some degree of specificity. But the notion that laws, especially if they're governing continuously varying phenomena, no law is absolutely precise. That was his claim. None. Zero. In other words, there's some point where at the next 100th or 200th or 300th significant figure, the measurement is going to be off. Now, he didn't take from that, we got a terrible problem. We don't know anything. We're not sure of anything. No, he just believed there's objective variation and chance in the world. And what we're trying to do with our rules and laws is limit it and capture as much of the order as we can. But there will always be elements of fog or haze of disorder around those laws.
Yeah, so it may be that actually heuristics, rules, and laws are more or less continuous and are just convenient segmentations into how noisy they are.
I personally am happy with that, although I'm not trained as an analytic philosopher of science. And I know historically they were dead set on the law's got to be, in effect, almost logically true. So it can't possibly have an exception. But I don't know what those are.
The physicists like to claim universal laws, and there are some that appear to be at least very large spectrum. For instance, sometimes people say, well, how do we know that the mass of the electron and the and proton and the strong force are the same over time and space? So actually, there is pretty strong evidence, and that is the spectral lines from very, very distant galaxies, 6-8 billion years in the past, halfway back to the Big Bang, and almost that far apart from us, show the exact same spectral patterns, which is essentially impossible to imagine if there were any even small, slight adjustments in the mass of the electron and the proton and the nature of the electric charge and the power of the strong force. All these things are highly, highly constrained. We're going to talk about soon that they are so highly constrained, but they seem to have been highly constrained across at least billions of years of time and billions of light years. So that's the class of thing that physicists say are lawful. That's always true, period. Right?
The laws of thermodynamics would still be true even if 1 out of a billion systems spontaneously created a lower entropy state.
And of course, that's the old, college sophomore thing. Well, it's under the law of thermodynamics. It's possible all the air in this room will collect in the corner and we'll all die, right?
Right, and it's not right. It's not
just
going to happen.
Exceedingly low probability for the whole history of the universe, but it's logically possible.
Right, but I mean, from my point of view, our laws are probabilistic.
Certainly thermodynamics is nothing but probabilistic. Right?
The achievement of very high probability is awfully good.
Yeah, as listeners know, my favorite word is useful, right?
Yeah.
That's my favorite word. All right, let's move on to where you actually do something a little unusual, at least in modern terms, and how you think about causality and Aristotle's 4 causes.
Right. So I do think you can pick up Aristotle's 4 causes and put them into contemporary science.
Well, for a benefit of our audience who aren't necessarily Aristotle nerds like you and I, explain them for me.
So the 4 causes in Aristotle are, think of them as the first 2 as matter and form, because those kind of go together. They're opposites, and you got to have both, matter and form. But then there's 2, so there's matter and form. Those, you need both of those for any substance, any independent, what Aristotle called substances, a substance is just an independently existing physical thing. So a chair, a table, a building, a squirrel, substances. So matter and form, matter is there's material stuff. Form means the material stuff has to be organized in such a way that it's a squirrel, or, it can't be unorganized. Form is organization. Then there's also got to be 2 dynamic things. One, the process that brought it into existence, what brought it here. And then lastly is the final cause, which is the end or goal of the thing in question. And famously, when we got to the 17th century, what modern physics had to free itself, not from form and matter, modern physics had to free itself from, above all, the notion of final cause, but also the notion of substantial forms, that the form is somehow fixed. And consequently, for a long time in modern physics, the view was that causality is either efficient, meaning there's a process of events leading to this next event, and simultaneously those also have to occur, these have to occur in matter. So material efficient causes. For philosophers in the last century, more and more decided you don't even need the matter. Causality is all efficient. So the cause of something happening is the happening before it occurred, something like that. Okay. And I think that's mistaken.
This is the radical determinism argument, essentially, that we sometimes see, that the Laplacian idea, if I knew where all the everything was in its motion, I could predict all of history and all of the past. Right?
Well, it's a couple of things. It's one, the notion that all causes are material and efficient, but it's also applying it to a particular ontology of the universe, which is we've just got particles moving around. And those are the only things we need to account for. So both. Now, my point would be that, for example, whenever you have complex emergence and there's something about an overarching system which is constraining or downwardly causing something to happen with its components, that's a final cause. Now, in inorganic phenomena, it's not, you don't have to use the word purpose at all. And it's this, you shouldn't. But actually, I think once you get to biology, you should. The tissues and macromolecules composing my heart are organized in such a way as to perform a function for my organism. It's called pumping blood. It's not as if that purpose, pumping blood, by itself caused hearts to evolve. It's rather that there's all this stuff was evolving in natural selection. But it is true that if the heart had not pumped blood, it wouldn't be there.
Yeah, this is the essence of top-down causality and upper and lower level coevolution, right? And this is, I think, what you were pointing to with final cause, and I think usefully so. And I'm like you, I don't mind using the word purpose once we get at least to the level of life. I used to be allergic to the word teleology due to having been raised a Catholic, and they use teleology in a way that I found highly objectionable. But I finally have found my way back to being able to just cross out teleology or final cause and say purpose, for at least within the realm of it.
We welcome you back. So what I would point out is what's very useful here is teleonomy.
Yeah, make that distinction. That was actually fun in the book.
So, and it's old. It's 50, 60 years old. And it wasn't invented by people who cared about emergence or anything. It was first developed by a guy named Colin Pittindra, and then picked up by Ernst Mayr, the great biological theorist. And his point was, and even then by Jacques Monod, M-O-N-O-D, who the Frenchman who wrote a book against Teilhard de Chardin. And, his whole point was to criticize Teilhard's teleological view of nature as a whole.
Was it the omega point? They were all headed for the omega point?
Yes, all that stuff. And it's amazing to this day, people look at that book and they, Monod, he's a hard-edged chemist and biochemist. He's throwing out this teleology stuff. But the whole book says, but teleonomy is crucial. We can't get rid of teleonomy. And teleonomy is directly connected to purpose. So here's the deal. Teleonomy in all these thinkers just means that there are things in nature, especially organisms, but not only organisms. It's also true of the thermostat in your house. There's things in nature that are organized in such a way, they are programmed, so to speak, cybernetically, to achieve a purpose. And whenever there's a departure from a desirable value, something in the system lurches into action to regain it. In other words, like a homeostatic mechanism. And that's true of the thermostat in your house, right? And it's also true of the living animal who, if it has a problem with temperature, it starts to shiver or it starts to sweat. That's teleonomy. Now, the point of teleonomy is teleonomical processes occur in biology totally without the involvement of mind, totally without it. In other words, the animal starts to shiver or sweat without thinking. The organism is designed that way. Teleology means that a mental content starts playing a role. Okay? And there's already purpose at the level of teleology. I mean, my favorite example is just that the bird is supposed to have two wings. It's supposed to. It's not a moral supposed to. It's got nothing to do with morality. Morality is human. Okay? But it's a supposed to. And if it doesn't, the bird has serious problems.
And from time to time, a bird is no doubt born with only one wing, but
That's right. And it has serious problems.
and generally doesn't live to reproduce.
That's right. And in the case of living organisms, since the 1950s, we actually know they are designed not by God, not by human beings, but by these macromolecules that are in their cells called DNA. So there is a set of sort of master molecules designing or controlling the production of proteins that are going to end up filling certain purposes without which the organism gets sick and dies.
But then, of course, higher level, there are new things going on as well. People are eating each other, which is at the level of biology, not the level of biochemistry.
Absolutely. Absolutely. The point would be teleonomy operates without mind at all. And it's perfectly legitimate to use the word purpose in there, not as some people say, oh, it's the mere appearance of purpose. Well, your thermostat has a purpose. You design a thermostat and put it up in your home. It will still have a purpose after you're dead. Because the purpose, it's not a thinking thing. It's not a living thing. It's not saying, oh, God, I got to reduce the temperature or raise the temperature. But it's designed in order to achieve an end.
In your language, it's a complex, right?
It's a natural complex, in this case, a very complicated natural complex, which has it's a living organic natural complex, which is built in such a way as to have certain purposes or goals or ends independent of mind. Then, if it is a minded organism, it's got additional controls that come from mentality, and you could call those teleological. Okay? So when my dog actually hears the dinner bell or sees the food, now I would say its pursuit of the food is teleological because there's a mental content involved. But that's all based on teleonomic processes.
The teleonomy is the actual mechanism. Teleology is a name we can give it when we want to talk about it being mentally motivated.
Right, when mind is involved.
But the fundamental is actually teleonomy, I would say, based on that.
I mean, so Meyer always had great examples. One of his examples was, so it's true that I can't remember the species of bird, let's say the swan, I don't know, but it's true that the swan flies south to avoid the winter. Now, that's a fact, and it's a historically present fact. We probably can find swans that don't fly, but they're messed up and stupid. But swans fly south for the winter, let's say. And he said, however, the biologist is capable of more knowledge than that. It's not just that the swan flies south and escapes the winter. It's that the swan flies south in order to escape the winter. And that's teleology.
Teleonomy or teleology.
Well, it's probably both. The dividing line would be if you say, if the cognitive system of the bird were destroyed, would it still do it? Then it's teleonomy.
Gotcha. Okay.
If the cognitive learning systems, it's probably based on learning. So if the higher mental functions of the bird, which are capable of learning new information, if they're involved, then it's probably, I would say it's teleological. So you may be right.
Animal behavior, it's always an interesting question. What is learned and what was inherited? Instinct versus learning in the life. And of course, now we know there's epigenetics in there as well, but just to keep it simple. And something like bird migration might be epigenetic, or at least a strong tendency towards.
I mean, I would assume that they're fixed action patterns.
So let's do a quick bridge from law and causality by way of complexity to your orders of nature. But let's talk about complexity in between.
From my point of view, and this to me might be a difference with Morowitz, not to tar him with this. I mean, he's doing what he's trying to show people there's all these thresholds of complexity in the natural world. I would say, on the basis of the way I use Wimsatt's notion of emergence, there's emergence all over the place. A stone wall might have emergent features, basically because, for various reasons, like essentially, if you can pull one stone out and the whole thing collapses, that means what was supporting it was a degree of complexity, and it can't just be decomposed and recomposed. There's nonlinear relations in the system. Anyway, but there's emergence all over. But remember that a system like a stone wall, only some of its properties require emergence as an explanation. So the rest can be reductively provided. Okay. So I'm not claiming that there's only 4 or 5 big steps of emergence in the history of the universe. There's emergence willy-nilly all over the place. However, it's useful and rather robustly indicated to say there's a whole bunch, not that many, not an infinite number, but more than 1 or 2, orders of nature, which means types of phenomena occupying certain scales that show a lot of emergent properties with respect to lower orders. This was true of emergence theory, but also what people used to call hierarchical systems theory, which comes up to the same thing, like Herbert Simon. And someone who just died last year, Stanley Southey, who was a real interesting biological theorist and basically a hierarchical systems theorist. Anyway, so what I said is this. Look, we can at least distinguish in nature as we have it, the physical order from the material order, which is primarily the home of chemistry, but also geology and related sciences. Then life, the biological order, it would be the third. Then the psychological or mental order, mind, which, as I would agree with you and Henriquez, it means animal mind. It's not human mind. Human mind's something else. And then the last level, which is at least on Earth, specifically human, is I call the cultural level. And if somebody says, gee, are those 5 the right one? What if there's 7 or 8 or 9? Well, I'm sure you could do that. So, for example, if you ask, where's social behavior? Okay, well, there's a lot of organisms with social behavior. And among living things, you can make very strong different distinctions between the animals that are social and the animals that aren't really social. And that affects then their mental behavior, etc. But I just claim there's at least these 5. And why these 5? One, we got a whole bunch of different sciences which have evolved, and it's not for no reason that we have different sciences. We have different sciences because we need them, and they're studying different things. And we cannot reduce the work of psychology to biology or biology. I mean, I think you can't. And even of chemistry and geology to physics, which would be the most controversial one. Furthermore, lo and behold, in the last 100 years, it looks like that list, physical, material, biological, mental, cultural, kind of maps onto the history of the universe. because they evolved in that order. That's the deal. So I'm saying at each one of these levels, we've got degrees of complexity, but you get more complexity as you go up the scale. You have entities and systems that span these scales. After all, I am a member of this socio-linguistic, culturally operating of this social system. I'm a human being, but I simultaneously have an animal mind, and I'm simultaneously a living organism, and I'm a material object based on physical rules about what happens to mass energy in my neighborhood. So that's true. So I go all the way up and down.
As we all do.
Yes, we all do, not just me.
And again, you take Harold and you and many other views of emergence. I like to think about, I think I stole this from Alexander Bard, kind of a classic amateur armchair philosopher, but pretty smart. We calls emergent vectors, that every emergence, until it stops surviving, branches constantly, right? So there's new emergences, and we look at life, it's this very complex tree of emergences, and I looked it up while I was prepping for the book. More than 30 times eyes have evolved in different branches of evolutionary history, and an eye is an emergent thing.
Was the reptile first?
No, it goes way, way, way back.
Way before?
Oh, yeah, fish had eyes for sure, right? And crustaceans have eyes, crabs have eyes, all kinds of people, and they're different eyes. Spiders have eyes.
Right, different eyes.
I think there's like 18 eyes just in the insect kingdom. It's nuts.
Oh, boy.
Right?
Well, I was way off.
So eyes are emergent in that the eyes track light or induce shape, etc. They actually do something. They have a purpose in your Aristotelian causal structure, and yet they've taken very different branching, mostly not cyclical paths to get there. And so the tree of life is just absolutely full of emergence vectors. So this is where I really wanted to get. You did make the case in the book, but you didn't. You may be able to say more. Why do you think the disciplines and these particular layers kind of co-evolved in our intellectual traditions? Is it because this is the fruitful division, or is it more chance? Is there some reason that the disciplines have evolved in a way that corresponds to this stack that you've laid out? And it basically does. You got low-level physics, you got chemistry, you got biology, you got psychology, and you have economics and the social sciences. So roughly speaking, our disciplines can be lined up against your stacks. Is it mere chance, or is there something about those particular, as Greg Henriques calls it, joint points in where we choose to carve the vectors of emergence? Any thoughts about that?
What I would say is we never really talked about my theory of knowledge, which we don't have to, but I'm a fallibilist. I'm a fallible realist. We have real knowledge of real things in the real world. It's never certain or complete. So I would say the fact that the academy has divided its inquiry into the world in the last, especially 400 years. I mean, we can start there because we can forget about medieval rhetoric and the teaching in the medieval universities, but start like with modern thinking and then the German university, etc. So the disciplines that students are subjected to today and that we get, intellectuals and academics get divided into, they evolved in a certain way. That they did, no doubt, has a hefty contribution of chance, but it's a symptom of something. So I say it's a symptom of something. I say it's a symptom that physics has different methods and different conceptual styles than biology. Chemistry, too, is in the middle. Chemistry is poorly gets forgotten sometimes, but they got different styles and different. I have one of my wife is also a philosopher, Elizabeth Baton, and anyway, one of her sisters is a chemist, and her father was a biologist. My father-in-law, who's dead, was a biologist. And when we would talk to the sister-in-law, who's the chemist, about biology, she would say, ick, soup. I don't want any soup. I want hard and fast distinctions.
Yeah, I want molecules. I want reactions. Right?
And on the other hand, they're famously, I don't remember who it was, but there was a physicist who, in the middle of the 20th century, when more and more particles were being discovered before the standard model sort of gave them order. And the physicist said, "What are we, chemists?" Because chemists have, like more than 100 elements to deal with.
Hundreds of billions of molecules probably at this point.
Molecules and compounds, yeah. And so these different methods have grown up to deal with different things. Someone would just say, was it by chance, in the sense, could it have happened differently? Well, how would I know? Anything could have happened differently. So I just take it as another symptom. It's a symptom of the fact that we've got a bunch of different things and we can't understand them all by the same method.
Now, interesting. I just read a paper a couple of days ago. I read this book, I don't know, 6 weeks ago. Now I think about it, this paper may have this is pure spitball in here, people. So if this sounds like I'm a fool, that's the way it goes sometimes. Erik Hoel's recent update of his paper on causality and emergence. And his argument is that what we call emergence are places in the stack that have the highest causal power downward. And
for downward?
Yeah, it has the strongest downward causality.
Oh, okay.
Right. And so one could say that perhaps without us, it kind of makes sense that if we say cutting the joint between chemistry and physics is causally powerful, so that we can say things at the level of chemistry that causes more downward causality in the physical domain than cutting it somewhere else. And the same could be true for biology. Then that could be a principled reason that these cuts happen to be where they are. I'm just going to think about that a little bit.
That could be, and another example that could be compared with that is Wimsatt himself. Wimsatt has this sort of wild essay called The Ontology of Complex Systems. And he distinguishes between these levels, what I'm calling orders of nature and levels. But he goes somewhat down the road of trying to give you criteria for understanding this. As he points out, most systems in nature tend to have most of their interactions with things of comparable scale and comparable energy level. I mean, the obvious is like the molecules in a gas. What are they interacting with? Now, they are being affected by the ambient heat of the room and everything, but they're bumping into and interacting with their peers, so to speak. And likewise, the macromolecules and then the cells in my body. There's then specialized systems in more complex objects that try to transmit influences from one scale to another, like my neural system. But anyway, his point is, most of the time, most of the entities of nature are busy, so to speak, in their day in interacting with things of comparable scale. And that's a perfectly adequate way to try to explain what they're doing, unless you discover that interaction is either better understood reductively from below or functionally from above.
Interesting. Yeah, that's good. I'm going to add another one to that. And I've been biting my tongue a fair bit because I'm working on a paper on a new theory of emergence. And one of the things I add is characteristic time scales.
Yes. Right.
And that may be more powerful than any of the rest. And yeah.
Correct. The shorter the time scale, the faster the set of interactions.
Yeah,
Is that what you're
so
talking
essentially,
about?
for instance, neurons' characteristic time is milliseconds,
Yes.
while the characteristic time of organic chemistry is nanoseconds. And so the two are very disjoint in that sense, right? The characteristic time of respiration is heartbeats is 1 second, for instance, right? So heartbeats are emergent from neurons, probably, because if only just looking at the time scales.
Right. And then when we get psychologically, I don't remember what the numbers are, but there's a lot of research on, okay, what's the minimum time to have an unconscious recognition of a sensation. Then there's a somewhat longer time for a conscious.
It's about 80 milliseconds for the unconscious, about 250 milliseconds for a conscious, barely a conscious recognition of an event. So it's on the order of a second also. But it's way above milliseconds at the neural level. At 1 millisecond, this is sort of between 80 and 250 milliseconds. So again, you would say it's way higher in the stack.
And in when one gets to the higher levels of, let's say, human self-consciousness, I use Damasio's notion of self-consciousness, it's not quite right to think as if the highest level is somehow controlling what goes on. On the contrary, the highest level is going to be the slowest, and it gets to play out its innings because there's lower levels that are dealing with stuff much faster.
Exactly.
Without which you'd be dead before the self-consciousness can wake up.
Yeah, that's
and
why
going.
I have vectored in on time scale as I hate one rule to rule them all, but I'm gonna do it anyway in this paper.
No, I'm sure that's time scale, spatial scale, maybe things like what you measure the relative energy of interactions, or the.
Another one that I've pondered is using similar mechanisms. For instance, neurons use synapse. It's a pretty broad collection of stuff, but it's still a tiny subset of all organic chemistry is used in synapses and firing of neurons. Organic chemistry, while a big, huge space, is a huge pruning down from all physical chemistry, for instance.
Yes.
And so the nature of the forces and relationships involved is probably also related, but I suspect less sharply than time. But we'll see. We'll see if I can land it.
Yeah. Fascinating.
Here we've been nerding out for our own sake, which is fine. My podcast, do what the hell I want. Here we have Lawrence Cahoone, who's a professor at a quite elite Jesuit college, right? You have extracted from your thinking and studying over your short life. We discovered in the pregame chat that Lawrence is about a year younger than I am, so I can refer to him as a young man with a short life so far.
Yes, and I bow to wisdom,
at least age, if not beauty. Right?
We've left beauty behind.
Long ago, right?
Although you do have much more hair. But anyway, we'll put that aside.
But anyway, let's hop, even though it's over several levels of things I would love to have talked about, but I have to go swimming with my granddaughters here at 3:00. Talk to me a little bit about the natural religion that you have come to think about due to this work in this area.
All right. Well, this, I wish I had never put this stuff in the book. Not because I don't think it's true. I have a bad personal tendency to, when I'm writing a book, say, I better put everything in here because I might not be here next week, so I better get it out. And there's a lot of philosophers. There are philosophers interested in philosophy of religion and stuff like that, but not that many. And the ones who are interested in natural science are not the ones who are interested in religion. But putting that aside, I would say, to try to say how this fits together with everything we've been talking about before, I am of the opinion that in trying to explain the origin and character of our universe, which did, after all, begin about 14 billion years ago, I would explain could not have come from nothing. And for a while, there was a view that it could have, and that makes no sense at all. Anyway, but
Yeah, well, Larry Krauss wrote a famous book on the topic, right?
right. And a guy named Tom Tryon also, and people picked up on it, but their nothing turns out to be really substantive nothing, the nothing that everything comes from. So anyway, this universe, which is everything we know, came from something. It also has these fine-tuned constants that fit into the equations of fundamental physics, but are not, as far as we can tell, determined by law. There's a lot of them. Physicists have been wondering about that oddity ever since the 1970s. I would take the view, no one, I would say, being a naturalist doesn't require for one moment that you ask, well, what explains this nature? How did it get here? You don't have to do that when you're a naturalist. But I'm a philosopher, and so I keep asking questions. So I do ask, where did it come from? And there's only two answers I'm aware of. One is roughly, let's just say the multiverse, meaning there's lots of universes and ours is one of them, the only one that has.
Yeah, the weak anthropic principle, right? That there's lots of universes, only this one supports life, or not only, but this is one that happens to support life of our sort. So of course we live in one that has this particular setting of parameters.
That's right. That's right. It's a bias. Our observation is biased because we're in the one universe that can be perceived at all, and that there's an endless number of other universes, etc. Now, that's one possible explanation. In other words, that the physicality, which constitutes our universe, is actually past infinite, past eternal. It was always here. It's just taken different forms. And our universe is the local form in which, okay, so that's one explanation. The other explanation, if there's a single ground of nature, otherwise called God, which is the source and informs and causes the Big Bang that leads to our universe. I don't think there's we're now into a speculative era. I don't know how anybody will ever come up with any evidence that one of those is more likely true than the other. But I will say this. Of the two hypotheses, namely, what explains this universe, it's the random development out of a set of an infinite number of other universes. That is the most extravagant physical hypothesis anyone could ever invent.
Well, you can add the other one, which is Everett's many worlds interpretation of quantum mechanics. And I actually read a cool book which stipulated both of them, right?
Yes, there you go. So, I mean, this is, if you want extravagance, that's it. I mean, nothing, I don't know what else you could invent that would be more extravagant and incapable of any kind of empirical justification.
Well, you could add another level that each of these things is an entity in a Boltzmann brain in an infinite universe on top of it. So that's one extra level of absurdity. But anyway, your point is,
okay. So my point is that the notion that there's a ground of being, what people would call God, is at least as plausible. I'm not trying to convince people to accept it. Having said that, I then say, but if you're gonna try to infer a God from nature, and you're gonna say, and someone will say, well, you can't have a God if you're a naturalist. I mean, I thought that was the whole idea of naturalism. You don't go outside nature. Well, I would say you could still be a naturalist if you just ask, what's the cause of the initial physical state of the universe? And if your claim is it's this ground, then you can still be a naturalist. Now, I don't want to drone on, but just to say it quickly, it also means, I think, if you're going to use that kind of naturalism to lead to your notion of the ground, then you have to pay the piper and only ascribe to God the things implicit in this kind of nature or universe. Which means, for example, there's no reason to ascribe to God omniscience and omnipotence.
Yeah, maybe, the clockmaker God set the parameters and walked away. Voltaire would have been fine with that, for instance.
Right. Well, it's not just a walking away. That God could be involved, but there's nothing about naturalism pretty much won't let you get away with the idea that whatever happens in nature has been designed by a good God in particular. That was Darwin himself. There's a wonderful quote from Darwin about design where he says, look, I can't believe, so one of his letters, somebody asks him, and Darwin says, look, I don't believe, and I can't believe that God designed all the particulars of this universe. And he particularly brought up that wasp that lays its eggs in a caterpillar. I can't remember what it is, but he knew about it. There's a wasp which reproduces by stinging a living caterpillar, planting its eggs underneath the skin. And then for several weeks, those little eggs eat out the caterpillar from within. Like in the movie Alien kind of thing. I mean, in other words, a horrible, horrible thing. And he's saying, God couldn't have made that, okay? God didn't design that. But then he goes on to say, however, if you want to say there's no divine purpose anywhere in the creation of our universe, that I can't go along with.
It sounded to me a fair bit like Spinoza or Einstein also, right? Yeah, and Voltaire and Thomas Jefferson, if we want to throw a few more sort of nature god / deists into the pot.
But as I would say, as opposed to Spinoza and Einstein, this world, at least because of its construction and the second law, is filled with hazard and disorder. So, not just natural evil, but hazard and disorder. It could be that it might not have worked.
In fact, if I ever write a philosophy book, it's going to be called Contingency and Necessity, or Necessity and Contingency. I make that point quite regularly. So, the wonderfulness of life. Well, you realize we don't get the hell off this planet in 600 million years. Sun goes super giant. We're all done. This particular emergence vector may have been for no count, right? And we always have to keep that in mind. Well, this has been one hell of a fun conversation. Could have done it for another hour and a half. I really want to thank Lawrence Cahoone when we talked about his very interesting and reasonably accessible book, The Orders of Nature. Thank you.
Thank you.
All right. Audio production and editing by Andrew Blevins Productions. Music by Tom Muller at modernspacemusic.com.